Hello guys, we are going to see indeterminations in this video. The idea is to review the idea of limit and try to solve some indeterminations. We will see which ones here. In fact, we are going to use one of the rules that you love most, is L'Hopital rules. If you know how to derivative a function, then this rule is for you. It's the one that normally I don't want students to apply, but students always apply it directly. Okay, what do you need in order to work with L'Hopital function? Yeah, for sure, basic algebra and calculus. L'Hopital rule involves derivatives, as I mentioned, so we need to calculate derivatives. So this could be a problem if you are not used to calculate derivatives. Also, we will perform some simplifications and limits. I think you can understand this perfectly. I will try to explain every step on the process. Okay, let's recall what an indetermination is. You are going to, when dealing with limits, the first thing you are going to do is to substitute directly and see what happens at the infinity field. So you can find something like infinity minus infinity. That's an indetermination because I don't know which infinity is bigger than the other. 0 times infinity, be careful. Don't say it's 0 because 0 multiplied by anything is going to be 0. In this case, it's something approaching to 0 and something going to infinity. The product is something I don't know. Okay, it's not 0 times something that approaches infinity. Okay, be careful with these ideas. Maybe it's a little bit difficult at the beginning, but later you will deal with this very, very fast and in a nice way. Okay, another two indeterminations that we find a lot of times, it's 0 over 0 or infinity over infinity. We have 3 more: 0 power 0, infinity power 0, and 1 power infinity. Again, in the last one, 1, you have something that approaches 1 and the exponent is going to infinity. It's not 1 power something that you all know that is just 1. Okay, let's start with L'Hopital rule. This is used to solve indeterminations of the form 0 over 0 and infinity over infinity. The problem, you are going to need to calculate derivatives. That's the only problem. But, okay, the examples you are going to see are very nice, and this rule is very useful in order to solve indeterminations. Conditions. When can we apply L'Hopital? For sure, when you deal with indeterminations of 0 over 0 and infinity over infinity. That's the main idea. Second, the two functions of the limit must be differentiable. Okay, we need to calculate the derivative of this function. And if it is not defined at this function, maybe you can have a problem. The derivative of the denominator must not be 0 at the point of interest. If we are going to calculate derivatives, we need to make sure that the denominator is not 0 at this point of interest. Okay? So, the formula, piece of cake, the limit when x tends to a of a function f divided by another function g, it's exactly the same as the limit when x approaches a of the derivatives, the quotient of the derivatives. Be careful, it's the derivative of the numerator divided by the derivative of the denominator. I have seen many times a small mistake in which you think that you need to calculate the derivative of the quotient. And this is completely different. We are just calculating the derivative of the numerator and put it on the numerator, and we calculate the derivative of the denominator and write it in the denominator, okay? Be careful just not to confuse this property with the derivative of a quotient. I have seen this mistake many times, okay? Example, let's see. We need to calculate the limit of sine over x divided by x when x approaches 0. First thing you need to do, okay, let's substitute x by 0. Sine of 0, all of you know that is 0, okay? Be careful with calculating trigonometric functions. At least you need to know the trigonometric functions and the main important angles, okay? Sine of 0 is 0. And divided by 0, if you replace x by 0, is 0, okay? So this is the first type of indetermination we have, 0 over 0. Perfect. we can apply L'Hopital rule. Sin if is differentiable function, x is a differentiable function. So let's try. If we apply L'Hopital rule, then what do we have? The derivative of sine is cosine. The derivative of x is 1. So the limit when x approaches 0 of sine over x is exactly the same as the limit when x approaches 0 of cosine of x divided by 1. Oh, but if we replace x by 0, we don't have any problem now. When I change x by 0 in this function, I got cosine of 0 divided by 1, and cosine of 0 is 1. So what do we have here? That the limit that started being an indetermination now give us 1. By the way, just a small remark in here, I don't want to spend much time in this. That means that sine of x and x, these two functions separately, goes to 0 at the same speed. Okay? We will be talking about this in more videos. Okay, another example. In this case is the limit when x approaches infinity, something new. Okay, we are not approaching a value, we are, x is tending or is moving till infinity. And the functions involved are e power x and x squared on the denominator. What happens if I just change x by infinity? Then what we are going to find is e power infinity, that is infinity by the way, and infinity squared, that is infinity. Okay, so what do we have? Infinity over infinity. Perfect. We are going to apply L'Hopital's rule, but now 2 times. Be careful with this example. We take the original limit and we calculate the derivative of the numerator. The derivative of e power x, by the way, it's e power x, so remains the same. The derivative of 2x is 2 times x. Okay? So if we substitute x by infinity again, what do we have? E power infinity, that is infinity, and 2 times infinity, that is infinity. Okay, so let's apply L'Hopital again. The derivative of e to the x is e to the x as before. The derivative of 2x is just 2 now. So if we replace by infinity the x, e power infinity is infinity, and infinity divided by 2 is infinity. So this limit, we don't have an indetermination anymore. We know that this limit is infinity, and we needed to apply L'Hopital 2 times, by the way. Last example. This limit, when x approaches 1, it's the quotient of the logarithm, natural logarithm of x and x minus 1 on the denominator. If we replace x by 1, remember that the logarithm of 1 is 0. And 1 minus 1 on the denominator is 0 again. So the indetermination we are dealing with is 0 over 0. Let's apply L'Hopital. Do you remember the derivative of the logarithm? It's very easy, and it's 1 over x. So the derivative of the logarithm is 1 over x. The derivative of x minus 1 is 1. So the new limit we need to calculate is this one. Okay, let me simplify this expression. 1 over x over 1, it's just 1 over x. So the limit when x approaches 1 of 1 over x is 1 over 1, it's 1. So the limit that we started working with that gave us 0 over 0 an indetermination, now it's 1. We just resolved this indetermination. Okay, what we have seen in this video, we just reviewed the idea of limits because as you could see, we have been calculating limits. And also we have learned how to deal with indeterminations of 0 over 0 and infinity over infinity. Is the only way to solve these indeterminations? No, there are many other ways, but in this video we just focus on L'Hopital rule. Okay, and we have seen some examples in which we have applied this rule. I hope this is helpful for you guys, and thank you for your attention.